The intersection of two sets, A and B, is the set of all elements common to both sets. So A intersect B can be written as A and B. So that's what that little symbol there means in mathematics. It means and or intersection of sets. It's where the sets have something in common. So if I have two sets here, A is 1, 2, 3, 4, 5, and B is 3, 4, 5, 6, each of these numbers are elements of a set. So those are the elements. And what is the intersection of these two sets? What are the elements that these two sets have in common? They both have 3, 4, and 5. So 3, 4, 5 is the intersection. And how we write that is the intersection of A and B is the set of these elements. 3, 4, 5. Close it up. So we're going to be looking at compound inequality statements where the solution is the intersection of the solutions for each of the statements. So for the first example, we have two inequality statements, and between them is the word and so that's how we know we're looking for the intersection of the solution sets here. So let's solve them. Let me solve the first one. X plus 5 is less than 9. I just need to subtract 5 from both sides so that x is less than 4. And if I were to graph that on the number line, I've got 4, everything less than that, not including. So then let me look at the other statement. 3x minus 1 is less than 2. I'm going to solve for x here, so add 1 to both sides, and 3x is less than 3. Need to divide 3 to get x by itself here on the left, and that says x is less than 1. So on the number line, 1 is to the left of 4. And the solution is everything less than, but not including 1. So those are the separate solutions. Now I need to look at the intersection. Where do these solutions overlap? What elements are in both of these sets? So you can see that there's both red and blue solution here, so negative infinity, until here. That's where the overlap stops, right at 1. Do we include 1? Only if it's included in both sets. In this case, it's not. So we won't include it in the solution of the intersection. And number 2, we want to solve the, again, and, so intersection of these solution sets. Graph it and write it in the interval notation. So let's look at the first inequality statement. 4x is greater than or equal to 0. So we need to divide 4 to get x by itself here, and 0 divided by anything is still 0. So I've got 0, and the solution set for this inequality is everything more than, so points to the right, and including, so equals. Now let's look at the solution set for the second statement here. So we're going to have to subtract 4 from both sides of the inequality to get 2x is less than or equal to negative 2. Then we have to divide 2 to get x by itself. Do we flip the symbol? No, we didn't divide or multiply by a negative number. There is a negative number over here, and that's okay. We didn't do that. It just happened. So x is less than or equal to negative 1, which will be to the left of 0. And so everything less than or including. So I'm looking for the intersection, which is the overlap of solutions for these two sets. There is no overlap, right? And so what that tells me is there is no solution. You can just write it in words. There's no way to show it as an interval because you can't have an empty interval, but you can have an empty set if you just want to write it that way. Either way you write that, that's fine. But that's the solution set for the intersection. Then in number 3 here, we've got a compound inequality that is the way we normally see compound inequalities. And that means it's got 2 symbols here instead of 2 separate statements. But it means the same thing. It means intersection. If you have 2 symbols here. So let's go ahead and solve this by focusing again in the middle where the variable is. And so we need to subtract 1 to get rid of that term from that side. So on the left side, that'll be 4. In the middle, that's a negative x. And on the right side, that's 8. Well, then we need to get rid of the negative symbol, right? So we're going to divide negative 1 from all of these sides. So left side is negative 4, middle is just x, and right side is negative 8. But we divided by a negative number. So that means we need to flip these symbols. And in this case, negative 4 being less than negative 8 does that make sense? No, that's not how it would be written on the number line. So that means we've got a bit of a problem here. And you'll also notice that the symbols are pointing the wrong way. So what we can do is we can break it up into 2 separate statements and say and, right? So we can say negative 4 is greater than x and x is greater than negative 8. And so that means x is less than negative 4 and x is greater than negative 8. Which should be written in this order on the number line, right? So let me use 2 different colors here for less than negative 4 and greater than negative 8. So that we can see the overlap here. And the overlap is everything between negative 8 and negative 4. And instead of going through all of that trouble, we could have said, let me just flip this entire statement. So the negative 8 on the right will now be on the left. And the negative 4 on the right will now be on the right. And that actually is exactly what this overlap says here. So either way we want to look at it, that works out just fine. And one thing I want to mention is if you're graphing this in the homework program, you'll want to be careful because they just want the intersection. They don't want you to graph both sets and show it that way. They just want you to graph the intersection. So be careful on that.